Hello folks, this is Jags here with part 2 of BCD driver integrated circuits, decoders and time multiplexing. So we'll kind of continue where we left off, and in the previous presentation, part 1 of this complete presentation, we looked at 7-segment displays amongst other things, and we looked at two specific types of 7-segment displays. One was a common anode and one was a common cathode. It simply means that the LEDs that make up the segments, each segment is an individual LED, and an LED has a an LED has a anode and a cathode. Conventional current flows into the anode and out of the cathode. Now, on this particular configuration, we have all LEDs, all segments are connected together. The anodes are all connected together. Now, for this reason, this is a common anode 7-segment display, and we've taken that to a high supply voltage. Whatever that supply voltage is, it's kind of irrelevant almost at this point. It would depend on what kind of technology is being used, but let's just say that it's a high supply voltage. Now, a 0 volts is at the bottom. Now, connecting that 0 volts to any one of the segments would complete the circuit. Would you agree? You'll have a higher potential going to a lower potential. So you have current going from the anode into the anode out of the cathode, and the current will be actually synced. This is called syncing the current, not sourcing the current. So whatever device that 0 volts is connected to, that's going to sync the current. This type of circuit is commonly used because most ICs can sync more current than they can source. I know it sounds odd, but that's the way it is. So syncing is sometimes preferred rather than sourcing. Now, another thing that I didn't actually look at was the decimal point. Most 7-segment displays have a decimal point. It's just another LED. I'm kind of concentrating on the A to G segments only. Now, if 0 volts is connected to any one of the segments, or a multiple of those segments, then those segments, corresponding segments, will be illuminated, and you can display your alphanumeric value on the display. Now, I'm going to look at a BCD 7-segment display driver IC, which has its outputs inverted. Now, this is commonly referred to as active low outputs. So we're looking at the driver now, remember, yeah? BCD to 7-segment display driver. Now, looking at the first row, we've got A0, B0, C0, D0, decimal 0. Now, had it been a normal input and output IC, then what you'd have is you'd have all the segments high except the G. Would you agree? Because that would illuminate a 0 on the 7-segment display. However, this particular IC has inverted outputs, active low outputs, which are giving the opposite result, and it's giving the opposite result for all the segments. Again, some of these driver ICs have active low outputs. I think the one I referred to in the lecture, I'm sure that had active low outputs as well. It's just one of the things you have to remember, and you can deal with it once you know what it is. So active low outputs, it just simply means that the output is inverted, and we'll have a look how we can connect this onto a 7-segment display to kind of still have the desired effect without much trouble. Okay, this is a BCD decoder driver which has active low output. So a block diagram of the device. We looked at the truth table for this device on the previous slide, and notice also it's got an active low enable. I've just kind of made this device up, that's why I'm not giving any number, but it's not a million miles away from a real device at all. So we've got 4 inputs, A, B, C, D, and we've got 7 outputs. I'm not showing the decimal point again, but notice that the circle at the end of the outputs indicate an active low value there, and also enable is active low. I've kind of made this completely active all the time in terms of the chip. The chip is permanently enabled because I've taken the enable control line to ground. Okay, so that's our thing. So BCD inputs A, B, C, D, outputs are connected to a 7 segment display. Now the 7-segment display is a common anode connection. That means that the anode of all the segments on the display are taken to a positive voltage. So a 0 at any corresponding segment will illuminate it. Can you see how this will work perfectly with the active low outputs? So a 0 is actually illuminating that segment. Therefore, even though we've got active low outputs, I'm just going to go to the previous slide. Even though we've got active low outputs, for example on the first decimal 0, those segments for a common anode will be illuminated. So it kind of interfaces with that particular driver very well. So a common anode 7-segment display interfaces with active low outputs beautifully, and we've got all the segments there. Okay. Now we've covered this before. This is a 2 to 4 decoder. So we've got 2 inputs, I0, I1, and we've got 4 outputs, Q0, Q1, Q2, Q3. And for this device, we also have an active low enable. Again, this device is permanently enabled. This chip is permanently enabled because I've taken enable to a ground. There's a constant 0 volts there. Now, the truth table for the decoder can be seen on the right of the block diagram of the decoder as such. So, a 0, 0 input means Q0 is high, a 0, 1 input means Q1 is high, a 1, 0 input means Q2 is high, 1, 1 means Q3 is high. Hope that should be kind of, you should be feel comfortable with that because we've covered these quite a lot before previously as well. So that's a 2 to 4 decoder. What I'm going to do is I'm going to combine everything now together to make an example circuit and kind of demonstrate what time multiplexing is. So we've got a PIC microcontroller or any microcontroller, and we're using 4 bits of a port. Why have I chosen port B? I don't know. I honestly don't know. It could have been any port, for example. And what I'm going to do is connect my 4 bits of my port to the BCD decoder, which has active low outputs. But the active low outputs are no problem because we're using common anode segments. But I'm going to connect the outputs to 4 7-segment displays. So A, B, C, D, E, F, G goes to all 4 7-segment displays. There's no way that the current can actually source or you can sync that much current simultaneously. So you can't have all 4 on simultaneously because the LEDs are going to be so faint because you're sharing the current that it'll hardly seem as though it's on. So we've got to just allow one segment to be on at any time. One segment to be on at any time. And what we're going to do is, in order to do this, we're going to use a 2 to 4 decoder and connect those to PB4 and PB5. So we're using 6 bits of a port here. And the outputs of the decoder are connected to common anode of the first segment, common anode of the second segment, common anode of the third segment, and common anode of the fourth segment. Okay, so we're going to place values on the ports now. 0, 0 will enable the first segment. Place a value on the port B, 0, so 0 is placed there. Okay, enable the second segment from the left. Okay, enabled. Output a value, 1. Enable the third segment. Output a value, 2. Enable the fourth segment. Output a value, 3. Okay, so in this way we can enable one segment at a time. However, if we do this very, very fast, in terms of our vision can't pick up the fact that the segments are going off and on all the time. And as far as we're concerned, at a certain refreshing rate, it'll seem to us as though all LEDs, all segments are on simultaneously, but just like the TVs, you can't see it flicker. It's flickering so fast that our eyes can't pick it up. It's the same kind of principle here. And we'll call this time multiplexing.